The unit for scientific measurements are internationally agreed and they are known as SI unit. What does SI stand for? SI stands for System International. And what does it mean? It means that these are standard sets of units which are precisely the same no matter where you are on the globe. So let us understand with the help of an example. Suppose that a person in China buys a piece of cloth which is 1 meter in length. Another person in Africa buys another piece of cloth which is also 1 meter in length. Suppose that we bring these two pieces of cloth together at the same location, and if we compare them, they should be precisely of the same length. Why? Because they are 1 meter. 1 meter in China is same as 1 meter in Africa. 1 meter elsewhere in the globe should also be the same. Right? So there are seven quantities. And their units are called SI base units. What are these seven quantities? Let's go through their names. Length measured in meters and its symbol M is a SI base unit. Mass kilograms kg. Time seconds. Temperature measured in Kelvin. Electric current ampere. The amount of substance mole, the unit M. The luminous intensity candela. These are your seven quantities and their units are called SI base unit. Right? And from these SI base units you can derive the SI unit for any other quantity. So I have my list of the seven quantities here. From these base units, we can derive the SI unit for any other quantity. Let us derive the SI base unit for a few quantities. So for example, let's start with volume. What is the formula for volume? Whenever you have to derive the SI unit for any quantity, you should know its formula. Think of any of the variant of its formula. Formula for volume is length, width, height. What is the unit of length? Meters. What is the unit of breadth? Meters. Height is also meters. So therefore the unit of volume is meter cube. Simple. Let us derive the SI unit for speed. Speed, the formula is distance over time. Distance is measured in meter. Time is measured in seconds. So the SI unit for speed is meters per second. This is the SI unit for speed. There are other units of speed as well. The distance can be also measured in kilometers. The time can be measured in hours. Then the unit for speed would be kilometers per hour. But this is not the SI unit. When we talk about SI unit, it is meters per second. Similarly, some of the other units of speed that we know of, miles per hour. And sometimes we can also talk about kilometers per minute. These are not the SI unit. The SI unit would have the constituent entities in the formula. Their unit should be mentioned in their SI terms only. Right? Now let us derive the SI unit for force. One of the formula of force that we know of is force is equal to MA. You can work with any other formula of force, it doesn't matter. There are several other formulas of force that exist. You can work with any one of them. So for simplicity's sake here, we are working with this formula. Force is equal to MA. Mass times acceleration. Acceleration is change in velocity over time. Now let us input the units. The unit for mass, if you check the table, is kg. The unit for velocity is same as the unit for speed, meters per second. Now these are the units, so I'll put them all in bracket. The unit for the time, if you check this list, is seconds. So 1/second. Time is in the denominator, second goes in the denominator. So what is the SI unit for force? It is kg meters per second square. This is your SI unit for force. Similarly, let's work on deriving the SI unit for energy. Can you recall any of the formulas for energy? Energy is same as work. One of the formulas for the work that we know of is force times distance. The unit of force we just derived, kg meters second to the power -2 times distance is measured in meters. These are all units, so I'm putting them in brackets. So the unit for energy would be kg meter square second to the power -2. So on and so forth. You can derive the SI unit for any other quantities in terms of these 7 SI base units that you see here.